Chapter 6 Combustion and Flame. Different types of fuel are used at home and in industry for various purposes. What fuels are used in our homes and industry as well as to run automobiles? Cow dung, wood, coal, charcoal, petrol, diesel, compressed natural gas, CNG, are used for various purposes as a fuel. You will see a burning candle. What is the difference between the burning of a coal and the burning of a candle? Maybe you were able to guess right. Candle burns with a flame but coal does not. Similarly, you will find burning many other fuels without flame. Let us study the chemical process of burning and types of flame produced during this process. What is combustion? You have learnt in class 7 that magnesium burns to form magnesium oxide and produces heat and light. Fig. 6.1. We can perform a similar activity with a piece of charcoal. Hold the piece with a pair of tongs and bring it near the flame of a candle or a Bunsen burner. What do you observe? We find that charcoal burns in air. We know that coal, too, burns in air producing carbon dioxide, heat and light. A chemical process in which a substance reacts with oxygen to give off heat is called combustion. The substance that undergoes combustion is said to be combustible. It is also called a fuel. The fuel may be solid, liquid or gas. Sometimes, light is also given off during combustion, either as a flame or as a glow. In the reactions mentioned above, magnesium and charcoal are combustible substances. Can you name some more substances which are combustible? You can add those to table 6.1. Let us investigate conditions under which combustion takes place. We find that air is necessary for combustion. When air can enter the chimney, the candle burns freely, in case A. In case B, when air does not enter the chimney from below, the flame flickers and produces smoke. In case C, the flame finally goes off because the air is not available. You will study in higher classes that heat and light are produced by nuclear reaction in the sun. You might have heard that when the clothes of a person catch fire, the person is covered with a blanket to extinguish fire. Can you guess why? Now recall some of your experiences. Does a matchstick burn by itself? How does it burn? You must have had an experience of burning a piece of paper. Does it burn when a burning matchstick is brought near it? Can you burn a piece of wood by bringing a lighted matchstick near it? Why do you have to use paper or kerosene oil to start fire in wood or coal? Have you heard of forest fires? Do these experiences tell you that different substances catch fire at different temperatures? The lowest temperature at which a combustible substance when heated takes fire in air and continue to burn is called ignition temperature. Can you tell now why a matchstick does not catch fire on its own at room temperature? Why does the matchstick start burning on rubbing it on the side of the matchbox? We find that a combustible substance cannot catch fire or burn as long as its temperature is lower than its ignition temperature. Have you ever seen cooking oil catching fire when a frying pan is kept for long on a burning stove? Kerosene oil and wood do not catch fire on their own at room temperature. But, if kerosene oil is heated a little, it will catch fire. But if wood is heated a little, it would still not catch fire. Does it mean that ignition temperature of kerosene oil is lower than that of wood? Does it mean that we need to take special care in storing kerosene oil? The following activity shows that it is essential for a substance to reach ignition temperature to burn. What happens to the empty paper cup? What happens to the paper cup with water? Does water in this cup become hot? If we continue heating the cup, we can even boil water in the paper cup. Can you think of an explanation for this phenomenon? The heat supplied to the paper cup is transferred to water by conduction. So, in the presence of water, the ignition temperature of paper is not reached. Hence, It does not burn. The substances which have very low ignition temperature and can easily catch fire with a flame are called inflammable substances. Examples of inflammable substances are petrol, alcohol, liquefied petroleum gas, LPG, etc. Can you list some more inflammable substances? How do we control fire? We have seen homes, shops and factories caught in fire. How can the fire be controlled from spreading? Generally, water is used to control fire. Water brings down the temperature of the combustible substance below its ignition temperature. The water vapor surrounds the combustible material, thus helping in cutting off the supply of air. So distinguished, you have learnt that there are 3 essential requirements for producing fire. Can you list these requirements? These are fuel, air, to supply oxygen, and heat, to raise the temperature of the fuel beyond the ignition temperature. Fire can be controlled by removing one or more of these requirements. The job of a fire extinguisher is to cut off the supply of air, or to bring down the temperature of the fuel, or both. Notice that the fuel in most cases cannot be eliminated. If, for instance, a building catches fire, the whole building is the fuel. Types of combustion: bring a burning matchstick or a gas lighter near a gas stove in the kitchen. Turn on the knob of the gas stove. What do you observe? Caution: do not handle the gas stove yourself. Ask your parents to help. Types of combustion in which the combustible substance burns rapidly and produces light and heat is called rapid combustion. There are substances like phosphorus which burn in air at room temperature. The types of combustion in which the combustible substances bursts into flames without any apparent cause is called spontaneous combustion. We generally have fireworks on festival days. When a cracker is ignited, a sudden reaction takes place with the evolution of heat, light and sound. The combustion in which large amount of gas is evolved with the production of a tremendous amount of heat, light and sound is called explosion. Explosion can also take place if pressure is applied on the cracker. Flame: observe an LPG flame. Can you tell the color of the flame? What is the color of a candle flame? Recall your experience of burning a magnesium ribbon in class 7. If you do not have experience of burning the remaining items in table 6.2, you can do that now. Record your observations and mention whether on burning the material forms a flame or not. Structure of a flame: in order to understand the structure of a flame, light a wax candle and water its flame. Carefully note the different colored zones in the flame. The substances which vaporize during burning give flames. For example, kerosene oil and molten wax rise through the wick and are vaporized during burning and form flames. Charcoal, on the other hand, does not vaporize and so does not produce a flame. In Activity 5, could the vapors of wax coming out of the glass tube be the cause of the flame produced? When the candle flame is steady, introduce a clean glass plate / slide into the luminous zone of the flame, figure 6.11. Hold it there with a pair of tongs for about 10 seconds. Then remove it. What do you observe? A circular blackish ring is formed on the glass plate / slide. It indicates the deposition of unburnt carbon particles present in the luminous zone of the flame. Hold a thin long copper wire just inside the non-luminous zone of flame for about 30 seconds. Notice that the portion of the copper wire just outside the flame gets red hot. Does it indicate that the non-luminous zone of the flame has a high temperature? In fact, this part of the flame is the hottest part. Goldsmiths blow the outermost zone of a flame with a metallic blowpipe for melting gold and silver, figure 6.14. Why do they use the outermost zone of the flame? What is a fuel? Fuels are substances that give us heat which we use for domestic and industrial purposes, such as wood, kerosene and petrol. A good fuel is one which has proper ignition temperature. It does not produce undesirable or poisonous substances and cause pollution. A good fuel produce a large amount of heat or have high calorific value. It is cheap and easy to handle. The type of fuel has low moisture content so that it burns easily. An ideal fuel does not leave behind much ash. We should look for a fuel which fulfills most of the requirements for a particular use. Fuels differ in their cost. Some fuels are cheaper than others. Make a list of fuels familiar to you. Group them as solid, liquid and gaseous fuels as in table. Fuel efficiency of a fuel depends on its caloric value. Suppose you were asked to boil a given quantity of water using cow dung, coal and LPG as fuel. Which fuel would you prefer? Give your reason. You may take the help of your parents. Do these three fuels produce the same amount of heat? The calorific value of a fuel depends on the amount of heat produced by complete combustion of 1 kilogram of the fuel. The unit used to measure the calorific value of a fuel is kilojoule per kilogram, kilojoules/kg. Burning of fuels leads to harmful products. Carbon fuels like wood, coal and petroleum release ash and fine unburnt carbon particles in the air which can cause respiratory diseases. Incomplete combustion of fuels such as coal, gasoline and other fossil release carbon monoxide gas which is very poisonous and kill the person sleeping in the room where coal is burning. Carbon dioxide released by most fuels during is causing an imbalance in the atmosphere. Deforestation is also leading to a situation where there are fewer trees to absorb the carbon dioxide. This is leading to global warming. 25,000 to 33,000 burning of diesel and coal releases sulfur dioxide gas whose corrosive in nature and causes irritation in nose, throat and airways. It also causes shortness of breath, wheezing and a feeling of tightness around the chest. Petrol engines release gaseous oxides of nitrogen. These sulfur and nitrogen oxides dissolve in rainwater to form acids and cause acid rain. The use of diesel and petrol as fuels in automobiles is being replaced by CNG, compressed natural gas, because CNG produces the harmful products in very small amounts. CNG is a clear fuel.